Good morning, ladies and gentlemen. My innovative idea consists on the design of a global 4G mobile communication network using the commercial aircraft network. So this picture this shows the increasing evolution of wireless communications, having 3G as the starting point towards LTE Advanced, which is the 4th generation. The arrow symbolizes the increasing demand for higher data rates and mobility. At the same time, lower delays, represented in the table by latency, are required so that user experience can be as real-time as possible. The most usual way to communicate nowadays is via terrestrial networks. As can be seen in the left side picture, coverage is divided into zones, each one having its own base station, and all of them are connected by cable, fiber, or radio waves. This represents substantial CAPEX and OPEX values. Other way of communicate, as depicted in the right picture, is via satellite networks, where you can see some low Earth orbit satellites, which are the ones that are closer to the Earth. Still, they are 800 kilometers away, requiring high energy consumption, not to mention that the terminals used in this type of communication are different from the ones used in terrestrial communications. Routes used by commercial air traffic, here represented by the green lines, cover a great part of the globe, with higher incidence in the areas where the use of internet per capita is higher, namely North America, Europe and Eastern Asia, as you can see. Little red dots, they can be really well seen. They represent the airports all around the globe. So, the idea. The main objective of this project is to have a global coverage network, or at least a network able to fulfill the needs of the user located in the regions shown in the previous slide, which use internet services the most and where traffic is denser.
Gisela, can you slow down a little bit for the benefit of the interpreter?
Okay, I'll just try to stick to the 5 minutes.
Yeah.
Okay.
We'll give you an extra 30 seconds, don't worry.
Okay. Users would be able to communicate to any part of the world. The nearest aircraft gets the signal, and since they are organized like a mesh network, it travels from aircraft to aircraft until it reaches its final destination. This way, aircrafts would transport not only people, but also information. So, with this project, users would get low delays, high data rates, consequently leading to an evolution of existing multimedia and data services, providing a better experience. This project represents a breakthrough in terms of evolution of communications, and one of its most important aspects is that it's also advantageous when analyzing it from an economic perspective. With this solution, it is possible to cover a great part of the planet using already existing resources. Since the network is composed by aircrafts, it's already built. And when compared to other solutions mentioned before, one can easily conclude that this approach is much more profitable. So there is no need to use different terminals, since the objective is to allow users to use the same terminal. And since implementation costs are low, this means that there is margin to reduce costs of provided services. Therefore, this will attract more clients in a time of crisis. For those living in remote areas where telecom companies do not invest as much as in major cities, this represents an opportunity to have access to information and to communicate. We have here, with this network, user terminals would be the same used for LTE or LTE Advanced, so there is no need to manufacture new terminals for this network, like I said before. This technology, the technology to be implemented is the same used in the future terrestrial networks, and so are the terminals. Moreover, the low CO2 emissions required contribute to a greener planet with lower power consumption. Once the technology is fully developed and trials are successfully done, I believe it's of paramount interest to society to implement this network. So there are regulatory entities responsible for the allocation of different frequency bands for different purposes. And it's their responsibility to assure that there won't be interfering bands. So this is why LTE frequency bands have a great margin to operate without interfering with the frequencies used in aeronautical radio communications systems. There's a slight overlap in the 1.5, 1.6 gigahertz, but there is much more spectrum that can be used to communicate. This would represent another means of communication other than the sometimes congested and consequently unavailable terrestrial networks. And also it would be interesting to consider the hypothesis of providing multimedia and data services to the passengers on board. So in terms of roadmap and implementation, it's expected that study, research and development will take 3 years. The next step would be starting to produce prototypes for, let's say, 1 year. And then the final phase is to proceed to field trials in this 5-year roadmap. Of course, that none of this can be done by itself. So all of this depends on the availability of partners to develop this project, such as university, R&D labs, and the industry as well. The most important factor, without which none of this is achievable in practice, is the financial support. So that we can have a team exclusively dedicated to the development of this project. And that's all. I hope you enjoyed my presentation. Here is my contact. If you are interested in this project, just feel free to send me an email. Thank you.
Okay. Thank you, Gisela. That was a very interesting presentation. The one thing that jumps out at me, though, at the end of that presentation, is I still actually don't understand what the proposal is. Are you now going to use aircraft to be, is it transponders or the communication devices, or are you proposing to actually provide services to airline passengers while they're in aircraft using satellite technology?
That's not the main question here. The main question is to provide the service to people on the ground. Imagine instead of using a terrestrial network or a satellite network to communicate, you use an airplane with the antenna inside of it.
So are you're going to fit, if you're like, telecommunications technology on board aircraft, so that as aircraft are in the ground, instead of me on my mobile, I'm actually communicating through the aircraft flying overhead as opposed to using the satellite or the terrestrial communications?
This can be used This can be used with the terrestrial networks as well.
Yeah. Speaking as someone who owns 300 aircraft, I think this is the most brilliant presentation and the most brilliant idea that I've ever yet seen. Clearly, obviously, providing water to the third world or photographing the artworks of the world's museums and inventing cultures are clearly very important, but as a selfish, rich airline owner, I'm all in favour of providing telecommunication services on our aircraft. I've got 300 of them, and I will certainly be signing up for this project. And I will be taking note of your email address and will be following up, because if you can find some way of me making more money out of my 300 aircraft as they're flying around, providing everybody with phone communications, I will be all over it like a rash, I promise.
Okay, thank you.
This is one, by the way, it is one of the areas that we in Ryanair are working on. It's one of the things I think the next future for us in terms of being innovative is in-flight entertainment. The problem for the airlines in terms of providing in-flight entertainment has always been it costs a fortune to fit all the seat backs with screens that people can't break, and which is kind of rubbish. Because where you've got everybody coming on board now with their tablets and their laptops and everything else. And it frustrates me that we can't yet get sufficient bandwidth from the satellite technology to allow people to use their own tablets and their own laptops on board our aircraft.
And also, when using satellite networks, the delay is huge.
The delay is huge, it's expensive, and you don't have a lot of broadband width. Now, I'm sure the amount of broadband width will increase, the cost of it will come down, but there is an enormous opportunity, certainly in the airline business. I have 75 million people on board 300 aircraft for an average of 1 hour 15 minutes each, and if I can give them access to the internet for 1 hour of that 1 hour 15 minutes, there's a great business for us, there's a great service for passengers while they're on board the aircraft, and there's a great business model for the telecommunications industry as well. So this is an area that we're very passionately focused on in Ryanair. So great idea. We'll certainly be following up, and if you can find some way of monetising 300 aircraft, I'll fund your research project, I promise you.
Thank you very much.